All right, I'll be honest, I'm lacking a little bit of energy right now. I'm super paranoid that I'm going to get the illness that's rolling around because I just spent $350 on concert tickets for Friday night. It's like my #1 musical artist is coming to town. His name's Joe Bonamassa. He's at the Orpheum. I can't wait. And I'm worried I'm going to get sick. What? His name is Joe Bonamassa. He's kind of like the premier rock and roll blues artist in the world right now. Super good.
When are you going?
If I get a fever, I will not go. I'll stay home. Yeah, Friday. So I know. So I'm just really worried. Crowd surf? Probably. Yeah, my kids will be there. So, all right, here we go. We pick up with number 3. Rational roots theorem. Again, one of the reasons why I became a math major. I saw it and I said, that's one of the coolest things ever. Okay? Absolutely love it. My favorite part of college algebra is this. Okay? My second favorite part is when we do the fundamental theorem of algebra, which is coming on up. But when we look at problem number 3, the first question we ask is, does it factor? And as you look at it, does it factor? No. But the truth is that we learned yesterday is that even things that don't look like they factor, we find ways to factor them, don't we? So the answer should be every time I ask you, does it factor? You should say, yeah. So I'll change the question. Do you see how that factors? No, we don't. So we have this beautiful thing in order to make a guess towards the factoring process. We use the rational roots theorem. The rational roots theorem says identify the degree, which is 3, and we should then find 3 factors. And it says identify the p's and the q's. Do you remember which one are the p's and which one are the q's? Yeah, q's are the first, p's are the back one. So I need factors of 3. 1 and 3. I need factors of q. 1 and 2. And so this is different because we have a lead coefficient different from 1. So we're going to take all the p's and divide them by all the q's. So 1 divided by 1 is 1. And 1 divided by 2 is 1/2. 3 divided by 1 is 3. And 3 divided by 2 is 3/2. And there we have a total of 8 choices. So again, of the infinite numbers that exist, we've narrowed it down to only 8 could work. That's pretty good. And in fact, we can narrow it down even more than those 8. The fact is that some of those are going to be bad guesses and some are going to be good. Pair and share for 20 seconds. See if you can figure out which ones are good guesses and which ones are bad. Go, talk.
-1. Yeah, it is. Don't think I took -1.
5, 4, 3, 2, 1. Can somebody tell me a bad choice? 3 over 2 is a bad choice. I'm even going to say that 1 is a bad choice. In fact, I'm going to suggest that any positive values would be a bad choice. Do you see why plugging in any positives will not work out? Yeah, you have all addition through here. So if you plug in a positive, it's just going to make it more positive, isn't it? So we don't plug in any positives. So let's start by just plugging in negatives. Which negative would you like to plug in? We try -1. 2 times -1 cubed will produce -2. -1 squared is 1 plus 9. And then 10 times -1 is -10, and then plus 3. So I have -2 plus 9 minus 10 plus 3. That produces? So it turns out that -1 works, so what's the factor? X plus 1 is the factor. So we're going to take that and divide it into this polynomial. I drop the 2, and what do I do after I drop the 2? I multiply, and I get -2. 7, -7, -3, and 0. Have to get 0. So we've learned this does factor. It factors to 2x squared plus 7x plus 3 times x plus 1. That's the factoring. Now, I ask myself, does 2x squared plus 7x plus 3 factor? It does. We have a 2x and an x And then is it going to be plus 3 and plus 1 or plus 1 and plus 3? Plus 1 and plus 3. What if it didn't factor? What would you use if it didn't factor? You'd use the quadratic formula. Quadratic formula always works, even if it doesn't factor. And so I see that my 3 solutions are what? Notice how he said that there will be no positive solutions, and in fact, they're all negative, and they are part of our choices. That is beautiful. You try the next one on your own all the way through. Go. I'm going to come around. As they're working well, I'm going to work just slowly behind you. Okay, let's pause and look up and see where you're at. I went through this process here, and I can see that I should have p's being 1, 2, and 4. Those are factors of negative 4, or sorry, 4, it doesn't matter whether it's positive or negative. Q's, the factors are 1 and 3. So you should have a total of 12 choices. Just to make sure on your test, I will be looking at all the choices you list and making sure that they are accurate. Okay? I divided 1. Did everybody get 1 to work out? Okay, so because I'm a reasonable teacher, I told you don't get a calculator on this test, I will not be making 4/3 and 2/3 and 1/3 the only ones that work. You know what I'm saying? Doesn't mean one's going to work every time, but I'm not going to pull out ridiculous numbers for you. Notice I try and I get 3, 13, and I get 4. So, you know, the fact is that does factor. If you couldn't factor it, you could go and use quadratic formula. But either way, you should come out with positive 1, negative 1/3, and negative 4. Those are your results. What do you think? All right, last example. Sir? Yes. So what makes this different is x to the 4th. And all of a sudden, you've heard us reference the quadratic formula. And in your brain, you're saying to yourself, well, we've heard about the quadratic formula to solve something if it's squared. Is there a cubic formula to solve something if it's cubed? And the answer is yes. It's about 1.5 pages long. I don't think we'd understand if we looked at it. It's rather involved, but it is pretty cool. They're like, is there an equation for the quartic, for 4th power? There is. It's about 4 pages long. And there is none for the quintic. In fact, there is no equation to solve a polynomial that's greater than 5th degree. But there is one for the cubic and for the quartic. And it's a pretty cool story. It involves a math duel. Yeah, they used to have math duels back in the day. Not making it up. Somebody did die. All right. So I've got P's and Q's. Notice how this one's going to be a little bit more involved, isn't it? Why? 48. So let's just put all of our P's down there. The Q's will be 1. But the choices will be plus or minus all factors of 48 because we have a 1 in front. What are my factors of 48? 1, 2, 16. Good. Good. Yep, those are the factors. And actually, I believe that for you guys being in the college algebra course that you're in now, that's one of the biggest things is people who sometimes aren't in this situation, they struggle to come up with some of those factors. So you guys early on were pretty good at your multiplication division tables, and that makes a difference. So good job. All right, I've got to try one. What do you want to try?
-1.
You want to try -1? Let's try 1 first. I got 1 plus 7 is 8, plus 8 is 16, minus 28 is like -12, minus 40. That 1's not going to work, is it? Like I've tried enough, 1's not going to work. I'll try -1. Now, if I'm Izzy, because I know Izzy pretty well. Izzy, we know each other, right? Izzy, do you ever worry that if you plug in a number here that you might make a mistake? Yeah. You don't worry about making a mistake there at all? Because I do sometimes. So can I show you what I do if I feel like I'm going to make a mistake? I actually, instead of plugging it in, I just roll -1 through synthetic division. 1, 7, 8, -28, and -48. And if it works, what should be the remainder? 0. I find when I work with synthetic division, I tend to make fewer mistakes as compared to plugging it in. I drop the 1, -1. 6, -6, 2, -2, -30. Did that work? No. So 1 and -1 do not work. What do you want to try now? I'll try 2. 1, 7, 8, -28, -48. One, 2, 9, 26, 52. Wait a minute, 24, right? 24?
Oh, yeah.
24,
I can't do mental math.
48, 0. All right, hey, worked. And notice what we get. What we produce is x cubed plus 9x squared plus 26x plus 24. Okay, so turns out that x minus 2 is a factor. Should I be trying to plug 2 in again? I mean, 2 could be a double root, right? But is 2 going to work in this situation? Why? They're all positive. We would have to try a negative, wouldn't we? So how about -2? Now I get 1, 9, 26, 24. Drop the 1, -2. 7, -14. 12, -24, 0. So it turns out that x plus 2 was also a factor. And so I have x squared plus 7x plus 12 times x minus 2 times x plus 2. Does x squared plus 7x plus 12 factor? To what? And so we can see that our solutions are, in fact, positive and -2, -3, and -4. Now, because I can't help myself, I just have to say, if we wanted to, could we graph it? So you don't have to draw this, but I just want to make this clear. If we plot 1, 2, 3, 4, and 1, 2, notice it goes through +2, -2, -3, and -4. It's 4th degree. Is it positive or negative 4th degree? Positive. So it's going to end going up, and because it's 4th degree, it's going to start and end same direction. So I start up, I drop down, they're all single roots. That's my graph. That quick. So notice how we've taken this problem and we've combined all the pieces we've done so far. And tomorrow we'll just go one step further and combine all of those pieces. So that's the opportunity you have to be able to ensure you're learning all the way. You guys have the rest of the time to work. Go ahead. I'll be around to help you.